folks, welcome back. In today's video, we want to cover the multivariable chain rule. Now, the multivariable chain rule is a super important generalization that we make that will help us with implicit differentiation and differentiation of a lot of different multivariable functions that might be a little bit more complicated than may seem. So in today's video, again, we would like to cover partial differentiation through the multivariable chain rule. We'll just introduce the topic, and then we'll dive in with some more worked examples in later videos. Okay, so the definition of the multivariable chain rule says that z is a function of x and y, as we know, but now we add a little twist to it because x will also be dependent on t and y will be dependent on t as well. So differentiating f of x and y is going to be a lot more challenging than just finding partial x and finding partial y. So what we do is instead we find dz dt by determining partial f partial x times dx dt plus partial f partial y times dy dt. Now, this seems very similar to the example for differentials that we covered in the last video, and that's because it is, because we are taking dy and dx as functions of t. They need to be accounted for in the derivatives. Of course, because these are both functions of one variable, we have whole derivatives here. If f of t and g of t, or if f and g were functions of x and y, or if f and g were functions of t in some other variable s, then we would need to add partial derivatives to the chain rule, but we'll cover that in the next video. So let's just try a super easy example just to start things off. Let's differentiate f of xy equals x squared y plus 3xy to the fourth, given that x is equal to sine of 2t, y is equal to cosine of t. So what we will do is we will plug this into the equation. So dz dt will be the partial derivative with respect to x of x squared y plus 3xy4. Times the derivative with respect to t of sine 2t, plus partial y of x squared y plus 3xy4 times the derivative with respect to t of cosine of t. Now to do this, here we move the 2 down, y stays constant. Here we get rid of the x. Here we bring the 2 out with the chain rule, change this to cosine. Here y goes out, here we bring down the 4, y goes down to 3, and then here we go to negative sine of t. So what we get is we get 2xy plus 3y to the fourth times 2 cosine 2t plus x squared plus 12xy cubed times negative sine of t. Now you can of course multiply this out and do all of your algebra with it, but essentially we've applied the chain rule to that example. That's a very easy example where you have parameterizations for both x and y. Okay, in the next video we will cover the idea of the chain rule when x and y are themselves multivariable functions of t and s. We'll see you in the next video.